Good day, guys. What we're about to tackle now is the sieve analysis or the particle size distribution. I will about to show you how to use this program or Excel file that I have been working for the past days. Here in sieve analysis, we are about to know how is the soil graded. In this table that I have made, you're bound to use the US sieve size, US standard sieve size, right? Here we have the sieve numbers and its opening. Usually there are a lot of sieve number, but it is the US standard, so it is the most practically used. In sieve number, there is the opening or its diameter. It's just different one. If you have different given diameters, then you can change this one. So we have the mass retained in each sieve season sieve, sorry. So it has mass retained, and in different sieve number there should be mass retained, right? So as we have to get the percent finder, we have to get the cumulative mass retained first. So in this, the cumulative mass retained in the sieve number 4, it still be the mass retained on it. And then the next one would be added to the next sieve number, and we get the cumulative mass retained for its next sieve number, which is the 6. So 0 still remains a 0, then so on. And for the percent finder, we all know that TM, the total mass, which gives this 450. So this is based on the example Sir Melo gave to us, one of his lectures. So in the percent finder, we have the total mass minus the cumulative mass retained over the total mass again, then times 100 for its percentage. So we can get here the different percent finder. Then as we get about to deal with the graph, here I have programmed it. I have put a chart on it. How does this program make you feel? In the particle size distribution curve that I have made, this shows how gapped the given was. But as we have been taught that um if the only given opening should be there, then this graph is not right. What you're about to do is remove the opening if the only given was those sieve number openings. So here, this is not included, so gotta delete it or make it a 0. Yeah, 0 and 0 0. It's the other 0. It would be left by just these dots. So with this, you can just manually put the lines in order for it to know the curve. So with this, we will not have any more gaps, as we have to just connect these dots. Sorry for it, because there is no certain code that we leave to get those lines according to just what is given. So with just this, we will just do this manually by putting a slide. So there's just a couple setbacks on how I make the Excel file on this one. So after the chart, we will now get the D10, the D25, D30, D60, and D75. In order for us to get the CC, the CU, and the SO, which gives us the grade of the soil or its classification. Classification, diba? Ganyan. So in D10, in order for it to be to to get it, we need to see the following. I mean the table that we have made. Where is 10% be located? And in your given and in the given example, you have this 6.933 and 20.356% finer in diameters 0.075 and 0.15. So we just need to input it on the sieve diameter. I didn't put any code on this because it should be manually observed and should be notified on the user. He should input this number sieve diameter and the percent finer that this sieve diameter holds. So within it, you can get the D10 here, which gives us the value of its diameter on D10. Sorry for that. For the D10, we know in the code we have the 0.092, and in between these two, it is present. So it is practically right as this code, strand code, will give us the value. If we change this, also this value for D10 would change. And the same goes for 35, 30, 60, and 75. You just need to locate where the 30% is in between the sieve numbers with its corresponding percent finer. As you move along, now we can get the CCCU and SO. But before that, we need to also determine the percent gravel, percent sand, percent fines, because some problems do need to indicate or know the percent of each different gravel, sands, and fines. So here we just in gravels we just need to subtract 100% to sieve number 4. So sieve number 4 have the 100% finer, so it is 0. But if it is 94 or anything ranges from that, you just need to subtract it to 100 because sieve number 4 holds the gravel. And then for the sand, it is the percent finer passing through 4 and up until 200. So with 100% finer, we just need to subtract it to 6.933. So you were able to get the 93.0067. And that 6.933 that passes through sieve number 200 will just be the percent fines. So after that, determining these percents for gravel, sands, and fines, you'll now get the CC. So the CC would be the sorry. So the CC is D10 over D60. Which give us this 4.478. And then for the CU, the D30 should be squared all over D10 times D60. Giving us this 1.004. Then for the SO, it is 1.987 by the square root of D75 over D25. So after it, we will now classify soil if this will graded and what it is in mixture. So here, to determine it, I have given this following what's this? Logical test. So you're classified to get to know that it is a well-graded soil with gravel or with sand by if CC is greater than 4, then it is well-graded soil with gravel. If it is greater than 6, then it is well-graded soil with sand. But if any of this will be below 4, then it is a poorly graded soil. So after determining the CC, if it is right, then we will need to move on to CU. We need to determine the CU, right? Because these two are the basis on how the soil will be well graded. If one is about to fail, then it is already a poorly graded soil. Here are the logical test again. If since we have given the parameters for CU to be a well graded soil, it should be that one is less than it, the CU, or it is greater than. Oh, okay. So mali day ko doon eh. Less than or equal to 3 also. And then we also have this logical statement that if our CC is already less than 4, then the display should be this. CC already didn't meet the condition, therefore it is truly a poorly graded soil. Sorry. And then the last statement is according now to CU. Since if your CC passed but your CU didn't make it, then it is still a poorly graded soil. And then for that, that is all problems that involves around sieve analysis with answered it by this program of Excel. That is all. Thank you.